The next topic we are looking into is the Earth's movements. These are notes from G.C. Leong. So the Earth is spinning in its own axis. So we'll be having the Earth, and this is the axis of the Earth, which is tilted 23.5 degree is the tilt of the Earth's axis. It is observed from west to east. The rotation of the earth, its own spin, is from the west to east. Therefore, the sun rises in the east and it sets in the west. From the north, the rotation looks like it is the anti-clockwise direction. But from the south, the rotation looks like clockwise direction. So the rotation of the earth, since majority of the people are in the north pole, we say that majority of the land is in the north pole. We say that the rotation of the earth is in the anti-clockwise direction. Specifically with respect to north, it is anti-clockwise direction, and south it is clockwise direction. Right now we have to see obliquity is the change in the angle of inclination. Now this must be the axis, and this is how it should spin, right? But here the axis is tilted. This is what we say it as obliquity. The axis is tilted and the tilt is 23.5 degree. Now obliquity is the change in the angle of inclination. Now obliquity ranges from 22.1 to 24.5. The tilt is changing. The tilt in itself is not constant. The tilt is changing from 22.1 degree to 24.5 degree. The time span of 40,000 years, and on average it takes for the tilt angle to change in the orbit is between the orbit is also now changing. Obliquity is axis change in the angle of inclination. Next we have, this is obliquity means change in the angle of inclination, that's all. Now we are going to look into the orbit. The orbit is also changing between elliptical and circular, that is eccentric. Our earth is not much eccentric. It is not eccentric. When it is so much of eccentric, it is qualified not to be a planet, right? Planets must have elliptical orbit around the sun. Now there is also the change in the orbit. The elliptical path is having slight changes over here. So the change in the axis angle of inclination is what we call it as obliquity. Right. Now the change in the orbit between the elliptical and circular, eccentric. Our earth is not much eccentric. Eccentricity in a long time span of like 1,25 years is when the eccentricity orbit becomes more circular to more elliptical. So obliquity is the change in the angle of inclination. Eccentricity is the change in the angle of orbit. The change in the orbit is what we call it as eccentricity. The change in the angle of inclination is obliquity. So we have studied two terms as of now, obliquity and eccentricity. Now we also saw the rotation. How does earth rotates? Along its own axis, and it is from west to east. The north pole, we say that it is anti-clockwise direction, whereas in the south pole they say that the rotation is in the clockwise direction, right? Now the next thing which is affecting is tidal forces of the sun and the moon. The tidal forces is responsible for wobbling of the earth on its axis. Wobble means this is, let us imagine this is the axis. It is shaking. It is shaking. First it is like this, then it is going, it is shaking, right? Like this it is shaking between west and the east, and then even between north and the south. It is just shaking. A shake is what we call it as wobble. So this wobbling of the earth, there is also wobbling of the earth, and the reason for wobbling of the earth is because of the tidal forces of both the sun and then the moon is responsible for wobbling of the earth on its axis of rotation. This is called precession, approximately 26,000 years. So as far as now we saw that obliquity, then we saw sorry, eccentricity, then precision. We have seen three important terms. Obliquity on an average is 40,000 years, and this is 1 lakh. Eccentricity, precision is just 26 years. Wobbling of the earth. So we know what is called as wobbling, right? Now this wobbling of the earth is because of the tidal forces. Rotation of the earth, we saw the rotation of the earth is nothing but it is spinning on its own axis. It is observed from the side west to east, from the north anti-clockwise, and from the south it is clockwise direction. Obliquity, rotation, obliquity, eccentricity, precision. Obliquity is change in the angle of inclination, is what we, there is a change in the angle of inclination from 22.1 to 24.5. This is also important, right? Then we have 23, right? So you go 22, you go to 24, 23 and a half, so 22.1, 24.5. This is how, and the time span is for average of 40,000 years. Next we have eccentricity, is the change in the orbit, and the orbit is also like 1,25,000 years, right? Then we have tidal forces is responsible for wobbling of the earth on its axis. This motion is called as a precession. This is approximately 26,000 years. Now we all know what is called as revolution. Revolution is nothing but the motion around the sun is what we call it as a revolution. The motion around the sun is what we call it as a revolution. This motion takes a time span of 365, 1 by 4 days. So 365, 1 by 4 days. So 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 is equal to 4 by 4 is equal to 1 day. Therefore, leap year, once in every 4 years, we have 366 days. These days are added, right, for 1 day. So 365, 1 by 4 is the time taken for revolution of the motion around the sun. Revolution of the earth, and revolution gives us seasons. Rotation, we have to know that what does rotation gives. Rotation gives day and night. So rotation, day and night is because of the rotation. Revolution gives us seasons, right? Now revolution of the earth and the effect on the seasons. Maximum population and 80% of the landmass is in the northern hemisphere. So everything we say that is a solstice is related to northern hemisphere, right? If in the question they ask just summer solstice, it is assumed that it is related to the northern hemisphere. If specifically they asked about some southern hemisphere, summer solstice of northern hemisphere is 21st June. You have to, so this summer solstice is nothing but the winter solstice of southern hemisphere. So opposites northern hemisphere, opposite southern hemisphere. This is the thing we have to keep in our mind, right? Now, summer solstice is 21st June. So, 21st June is the summer solstice with respect to the northern hemisphere. The north pole, we can say, is inclined towards the sun. December 22nd is winter solstice with respect to northern hemisphere. Therefore, the southern pole is inclined towards the sun. So this is the summer solstice for the southern pole, right? December 22nd is the summer solstice and June is the winter solstice. 21st June, the sun rays are vertical, straight vertical to the Tropic of Cancer. Above Arctic Circle, Norway, Sweden, Denmark, they have full light. So above the Tropic of Circle, it is always full light, right? In 22nd December, the sun rays are vertical in Tropic of Cancer. Therefore, Arctic Circle is full darkness. Equinox is sun rays are vertical to the equator. When the sun rays are vertical to the equator, it is called as equinox. When the sun rays are vertical to the Tropic of Cancer, it is called as solstice. or the Tropic of Capricorn, it is called as solstice. You have to know the difference. Sun rays are vertically ahead to the equator. Only for the equator we call equinox. Only for the equator we have right? So equinox. Land of midnight sun is in the Norway, 21st June, where the sun is for 24 hours. Midnight also you are having sun. Between the Tropic of Cancer and Tropic of Capricorn, the sun rays are vertical. Other areas are slanting. So between the Tropic of Cancer to Tropic of Capricorn, only the sun rays we see vertical sun rays. Other areas we see slanting sun rays, right? So these are the slanting sun rays. So in remaining areas we see slanting sun rays. Once again, let us go for it. Between the Tropic of Cancer and Tropic of Capricorn, the sun rays are vertical. In other areas, we say that the sun rays are slanting. 21st June, we know the Cancers behave like a thermal equator. Heat, how the heat is in the equator. 12 hours of day and then we have 12 hours of night. 32nd, 22nd, okay, sorry, 23rd September is when the sun rays, and then we have 21st March is when the sun rays on the equator, equal day and night, equal nights, okay, equinox. The formation of the season, revolution around the sun and its inclination must. So what is the reasons for the formation of the seasons? First, we have the revolution. It is rotating on its own, which causes day and night. It is revolving around the sun. Revolution around the sun is giving it seasons. But why does the seasons in specific? See, it is revolving around the sun also. If it is very straight, half of the receives sunlight, entire half is receiving sunlight, and the entire half, so day night, equal day and night. If the tilt is straight, okay, let us see why we have seasons. Seasons like summer, autumn, winter and spring are the 4 seasons, right? Now see, this is straight line, but the earth is having a flat pole, right, and a bulgy equator. This is the tilt. This is the tilt, which is 23.5 over here, and from here if you see, the tilt is 63.5 over a plane. Okay, now see, the sun is here, right? Now whatever it rotates from west to east, even though it rotates from west to east, only the southern hemisphere is receiving the sunlight, right? The northern hemisphere doesn't, because it is, even if it is rotating, the northern hemisphere doesn't receive the sunlight. That is why here, if it is winter, here it is autumn, here it is spring, here it is summer, right? Here it is summer and here it is spring, but here we have 24 hours of light, right? So this is the reason, the tilt is the main reason. Even though earth revolves around the sun, the tilt is the main reason for having seasons. So revolution is a reason for the seasons. We can say that revolution is a reason, but we also have tilt is the major reason for seasons. Inclination is must. This inclination is responsible for variation in the day and the night. So why does there is a variation? We say that there is variation in day and night. This variation in day and a night is because of the seasons. So we say, and this variation in the day and night and the seasons are because of the inclination. It is inclined, plus it is also revolving around the sun, right? These are the 2 reasons why we have seasons, and there is also variation in the day and then we have the night. Now we are going to see about the latitudes and longitudes. Latitudes are equidistant circle. Equidistant circle. Equator is the longest and at the poles it is the shortest. Equidistance, okay, we are not saying equi-length, right? Equal distance, but longitudes are equal length. So we have to say, we have to first know what is latitude and longitude. Now this is horizontal, this is horizontal. Now in H we have only one line, right? So we have to remember this line. For horizontal means this is horizontal. When you put H, you put two straight vertical lines and one horizontal lines, right? This horizontal, one horizontal line, so H means this is horizontal. Sometimes we get confused, right? And for vertical, if you see, this is vertical, right? V for vertical, right? So both the lines are vertical in itself, so there should not be any confusion. Now latitudes, when we are looking onto the latitudes, 0 degree, 1 degree. 1 degree is the distance between two latitudes, equidistance, whereas longitudes are equal length. Now see here, this is big, this is, while decreasing in the size as it moves towards the poles, right? It is decreasing in its size, whereas the distance is always same with respect to the latitudes. Now equidistance circles are what we call it as the latitudes, or equidistance circles. Equator is the longest and at the poles is the shortest, and the distance between the latitudes is 1 degree. Now how do you tell about 1 degree? 1 degree is nothing but triple 1 kilometer. Easy, 1 degree is triple 1 kilometer, right? 1 degree is triple 1 kilometer is 1 degree. Now temperature coordinates. How sunlight is moving through the earth. It is used for measuring the temperature. Latitude is used for measuring the temperature. Let me tell you by drawing the model earth. Now first the earth, sun is here, straight, and then the sun goes to this point. Again sun comes down, the sun is here. So whenever the sun is at the vertical, we have high temperatures, right? The sun goes through this, right? So latitudes are used. So here we can say that it is hot. If here it is hot, this entire latitude is having cold, right? So latitudes are for temperature coordinates. We have two things, then we have time also, right? Longitudes are for time. Now because west to east the earth is rotating, right? The earth is rotating from west to east. So here the sun is in the, sun rises, right, in the east. So here it is night. Night. Here it is day. So day 6 o'clock, 6 p.m. for example, right? So this entire latitude receives same amount of temperature. So latitude, entire longitudes receives the same amount of temperature. Longitudes are for time and latitudes are for temperature. Latitudes are equal distance, so we say equidistance, and they are circle, complete circle. The distance between the latitudes is 1 degree or triple 1 kilometer. Latitudes are equal distance, equidistance, and they are circle. The distance between the latitudes is 1 degree is triple 1 kilometer. At the equator they are the longest, and at the poles they are the shortest. Temperature coordinates, they are used for temperatures, right? So we call them as a temperature coordinates. Sunlight is moving through the earth. They never meet. But longitudes, they meet. Because we have the pole, right? No, this doesn't represent earth. Longitudes meet. Little flat. Let us keep it. In bulge. This is the longitudes, right? All the longitudes are meeting, right? Whereas latitudes are complete circle and they never meet. They are parallel to each other. They run they are not parallel. See, do you think this is parallel over here? Now longitudes are semicircles. Half the circle is what we have the longitudes. They are for time. All the longitudes are converging over the poles. Maximum distance between the longitudes is at the equator. Yeah, the meridians. So 1 mile is 1.6 kilometers. So 25,000 miles is 40,000 kilometers. Not sure why this is being written here. Torrid zone is a high value of biodiversity, rainfall, and productivity. When there is high biodiversity, rainfall, and productivity, it is called as torrid zones. 0 degree longitude. So Greenwich meridian, we have an observatory, right? International agreement at the Royal Astronomical Observatory. They fix a place in London as 0 degree. They are fixing longitudes, right? So they fix 0 degree in 1884. There was an international agreement, and this agreement was at Royal Astronomical Observatory at the Greenwich near London. This 0 degree is prime meridian. The circumference, Earth is spherical. The circumference is 25,000 miles. So now we understand why 25,000 miles is the length of all the longitudes are similar, right? So it is 25,000 miles. So the length of all the longitudes is 25,000 miles. Right. The linear distance of each 365-degree longitude is 25,000 divided by the 360 degrees. Longitude divided by the latitudes is what we get is 29.1 miles is the distance between the latitudes are always same. So the latitudes are used for calculator. International Standard Time, right? 0 degree longitude. Indian Standard Time is we have 82.30 east. We have the Indian Standard Time is 82 degree 330 seconds east. We have the Gujarat, right? Here we have 68.7, and we have in Arunachal Pradesh 97.25. We add both and divided, the central point is 87 degree point 30, sorry, 82.30 to 3. We are in east, right? 68.787 92.25 97.25. 68 and then we have 7. 97 we have 25. Then we have 82.3023, right? So 68.7, 97.25, 82.3 is the Indian Standard Timeline. For 24 hours, the angle formed is 360 latitudes, 180 in the west and 180 in the east, right? So 1 hour is 360 divided by 24 is 15 degrees. For 1 hour, 15 latitudes, 15 degrees is equal to 1 hour. If two distance is separated by 15 degree, their time difference, if two places is separated by 15 degree, their time difference is 1 hour. So for 24 hours we divide the 360 longitudes, 360 longitudes. So 360 divided by 24 is equal to 15. So we have 60 minutes. For 1 minute it is 4 degree longitude. Sorry, 1 degree is 4 minutes. For 1 degree longitude we have 4 minutes, and for 1 hour we can cross 15 degrees. So for 1 degree it takes 4 minutes to cross. 1 degree it takes 4 minutes to cross. The time difference between 1 degrees is 4 minutes. So 1 degree distance is 4 minutes time. Earth rotates from west to east. So for every 15 degrees we go, local time is advanced by 1 hour. Every 15 minutes we go westwards, west to east, right? East is first seeing the sunrise. Advancement. Here if it is 5 o'clock, here it will be 6 o'clock. 6 p.m. is what we say it as advancement, right? It is, see here if it is 6 a.m. in the morning, here it will be 5 a.m., right? So this is what we say it as advancement. It is advanced. That is, the time is east, EGAWLS. So the earth moves from west to east, right? We know that the earth moves from west to east. Every 15 degree we go eastwards. So local time is advances, you have to add 1. For every 15 degree westwards, you have to time is lost, so you have to retard 1. Time is lost in the sense local time is retarded is what we say. West lost and east is gain. If both are in the same hemisphere, we say big value minus small value. If both are in the different hemispheres, we need to add it. Longitudinal distance into 4 is minute value. Longitude into 4 is minutes, right? Minutes divided by 60 is hours. East gain, west loss, subtract. East gain, add, EGA, right? Now let us solve a question. If it is noon at Allahabad, what is the time at Lahore? So Allahabad is where we have the Indian Standard Time, 82.30, right? If it is noon at this is Lahore, right? So here we have Allahabad, here we have Lahore. It is towards west, right? West is lost, we have to subtract. So if it is 12, we have to subtract. So first you need to subtract 82.30 minus 75, 7.35. 7.30 divided by 4 is what we have into 4 is what we have the minutes, right? 32 minutes. 32 divided by 60 is what we have the hours. If it is 12 p.m. minus 32 minutes is 11.28 is the time at the Lahore. Chennai is 80 degree east. It is 7 p.m. The time in the New York is 75 degree west. Now, as we already told that both are different hemispheres, east, west. So we need to add. After adding, we need to into 4 is when 620 minutes. 620 minutes divided by hour. Now we say New York is here and Chennai is here. West and then east, we know the time of the west, we need to find the east. So east is, we have to subtract 7 p.m. minus this 10 hours, 10.33 hours. So it is 7 p.m. is, you go for 0 a.m. 12 a.m. is when minus 7. So even 12 a.m. if you are going to 3, what it is going to happen? It is 9 a.m. So from 9 a.m. you subtract 33 minutes, you have 8 a.m. 8.27 a.m. right, of the same day. 1 p.m. is in the Greenwich, a place is at the 6 a.m. So we have p.m. a.m. So this is p.m. then we have the a.m. right. Just different, there's 5, 4. We know Greenwich is 0 degree, right? If it is 1 p.m. in the Greenwich, it is afternoon, but some place is having morning, right? So if it is afternoon here it will be evening. So here it is going to be morning. Now we have 6 p.m. is 6 a.m. right? Now, if it is 1 a.m. over 1 p.m. over here, this is 6 a.m. The difference is 5 hours, right? Now 5 hours is, first we have to convert it into degrees, right? So for hours we need to do 1 into 1.5. It is 75. So 75 degree, it is west. This place is at the west. It is not east. USSR is the largest country which is having 11 time zones. Canada and USA are having 5 time zones each. These are the time zones: Atlantic, Eastern, Central, Mountain, Pacific time zones. This is 180 degree west and 180 degree east. Both are at the same place. Here we have west, here we have east, right? So west is loss subtraction, east is gain add. This is international time zone. 21st June we have sunlight at the Tropic of Cancer. After 21st June the sunlight will not cross the Tropic of Cancer. Similarly, 22nd June is the sunlight in the Tropic of Capricorn. After 22nd June it will not cross the Tropic of Capricorn. 22nd December is summer solstice of the Australia. Winter solstice of Australia is in 21st June. Spring equinox, spring equal time. So the spring is, after spring we will be having the summer, right? Spring equinox, not, it is solstice, is 23rd September. Yeah, correct. It is spring solstice of Australia. Spring equinox, guys. So first equinox is equal time in the equator. So if it is March, then it goes up, right? April, May, June, it goes up. So here it will be, if it is 21st March, let us assume it is 21st March, then it goes here. Here it is summer. First, initially here it is summer, so here it is spring. So when here we have spring, here we have autumn. So autumn equinox is 21st March of Australia. And then if here it is, then here it comes for the, then further it goes here, right? So this is September 23rd, it comes here. So if it is summer over here, next place it goes over here, therefore it is spring. So it is spring equinox of Australia. Given the date, which city is hot? Remove the cities, and we have to remove from the northern hemisphere, and we have to remove the cities from the eastern hemisphere also. 1 degree is 4 minutes. Angular measure of 1 degree is 60 seconds, right? So 60 minutes. Angular degree and angular measure of the degree. This is measure minute as a unit of time and minute as a angular. This is related to max. We are not looking into max over here, right? So usually minute as a unit of time, when we take 1 degree, is 4 minutes. You know what is coordinates, right? Latitudes are annular distance of a place measured in degrees from the center of the earth towards the north-south and the north and the south of the equator. It is measured from the center to the north, and then we have the south, right? Parallel lines cannot connect points with the same latitude. Same latitude points are getting connected. Parallels of latitudes are always parallel to each other as well as to the equator. The length of each latitude decreases towards the pole, and the distance between two latitudes always remains the same. Distance between the two latitudes is 1 kilometer or 69 miles. 1 mile is 1.6 kilometer. The circumference of the earth is 40,075 kilometer is the circumference of a complete circle. At the center is 40,075 kilometer. Longitudes are vertical or the semicircles. Prime meridian is where we have Greenwich Mean Time. The sum of two opposite meridians is always 180 degree. Sum of two opposite meridians, west plus oppositely, exactly opposite to that meridian, we'll be having 180 degree. Annular distance of a place east west of a meridian. Great circle. Largest imaginary circles which cuts the earth into two halves is what the great circle is. We can draw infinite circles. A circle with the longest possible circumference drawn on the earth along the equator, latitude's equator, is only one great circle. And every meridian of the longitude forms the part of the great circle. Latitude, with respect to latitudes, we have only equator, right? That you can cut from here, anywhere you can cut the earth, right, into half. So there are infinity great circles, but along the latitudes we will be having only one, the horizontal, we will be having only one, that is the equator is a great circle. The great circles is used in navigation. The shortest distance between two places, you have to draw a circle, right, and then cut the circle, and it is the shortest distance between the two places. Now we have this place and then this place, right? You can tell that this is the shortest distance, but you have to draw a circle and then cut the circle equally. This, then the distance you have to take, this is the shortest distance. The straight point on the map is not the shortest distance. This is the shortest distance. Because the latitudes are imaginary on a curved surface, the latitude is not the shortest distance. This is actually a curved surface, right? So the great circles are used for navigation. This is the shortest distance, because here there is a bulge over here. For shortest distance between 2 points, the great circles are the connecting points. Greenwich meridian is what we call it as a prime meridian. Rotation is the spin motion of the earth around its own body, is what we call it as the rotations. And 2 points are stationary, there is the north pole and then the south pole are stationary. Whereas the equator must to rotate very fastly to complete 24 hours. Therefore, there is a bulge because of centrifugal force. Lines passing through these stationary points are called as axes. They are stationary points because they are just a point, right? Then how does this point have rotation? So there are a line passing, there is a line which is passing between the 2 points, and this line is what we call it as the axis, and this line is what we call it as the axis. Around the axis, the body is rotating. Remaining any points other than North Pole and the South Pole are not stationary. Remaining any points other than the North Pole and the South Pole, they are not stationary. So are there any stationary points? No, there are not stationary points except the North Pole and then the South Pole. What is a great circle around the latitude? The equator is a great circle around the latitude, right? Every longitude in itself is a great circle because it cuts the earth into two halves. And we have infinite great circle. The great circle is used for navigation. Now we have stationary points as North and the South Pole, and we have the equator which is passing, sorry, not the axis, the axis is passing between the North and the South Pole. We have only two stationary points, right? The plane in which the earth is revolving around the sun is what we call it as the orbital plane. There is a plane in which the earth is revolving around the sun, and this plane is what we call it as the orbital plane. So sun, earth revolves around the sun in this elliptical path, and this elliptical path, the plane, this center plane is what we call it as the orbit. The plane in which the earth is revolving around the sun is what we call it as the orbital plane. The angle between the earth's axis of rotation and the orbital plane, earth is rotating, right? And then this plane, so this plane and the rotation of the earth is this tilt. So earth, this is the orbit, this is the plane, right? This is the orbit. So the orbit and the plane are touching. This is 66.5 degree, right? The angle between the rotation of the earth's Earth's axis, and the plane, orbital plane, is 66.5, and it is not 90 degree because there is an angular tilt of 23.5 degree. This is a perpendicular normal. This is how the equator in itself is looking like, 23.5 and 66.5. This is the orbital plane. So this is what we call it as a orbital plane. Rotation is the movement of the Earth around its own axis. The axis of rotation is an imaginary line passing through two stationary poles. There are only two stationary poles, that is North Pole, and then we have the South Pole, and the center of the Earth around which it rotates. Orbital plane is a plane in which the Earth's orbit around the Sun. The angle between the axis of rotation and the annular plane is 66.5. The angle of tilt of the Earth's axis from its normal position is 23.5. The direction of rotation, the North Pole, is counterclockwise. That is anti-clockwise direction is the rotation, and then we have the South Pole is clockwise. West to east is the rotation. The period of rotation, the time taken to complete one rotation, is 24 hours. 1 is Sun, 2 is the distant star. Right, 23 hours 56 minutes. You have to take 4. Just 1 by 4 is there. No, 365. 1 by 4 is the time taken for revolution. Right. Now the same thing you can apply. 4 alone you need to take 23 hours 56 minutes. The time taken to complete 365 degree. Sidereal day versus the solar day. When it is sidereal day versus it is solar day, right? When a solar day is 24 hours, whereas the real time it takes for the rotation is 23 hours 56 minutes. Therefore this is called as a sidereal day. For calculation purposes, we have kept that one solar day, because day and night, because of rotation we have day and night, the rotation, and with respect to Sun we have day and then night, right? Therefore we call a solar day is 24 hours, whereas one sidereal day's motion of the Earth is from point A. It is starting from point A and then it starts to rotate, right? Come to the same point. It starts from the point A. It goes and comes to the same point. It takes 23 hours 56 minutes, but we have kept 24 hours, right? So just 4 minutes. If we take, this is the rotation, right? We take it as 24 hours. So the rotation we consider, the normal rotation is this, but the rotation we consider is 4 minutes extra, right? So this point from A to the B point, right? This is solar day and this is sidereal. The difference between these two is 4 minutes is the difference between these two. Solar day and then we have the sidereal day. The difference between these two is 4 minutes. Sun, Earth rotates as well as revolves. To see the overhead Sun again, rotate 4 minutes again. To see the overhead Sun, we have to go for another 4 minutes. Then only we will get Sun. The Earth is rotating for 23 hours 56 minutes time to reach the same point. But at the same point, you will not see Sun because the Earth is rotating as well as revolving. The revolution will cause the Earth to see from here. It is starting at A and reaching at A. But this entire ball is moving, right? It is revolving as well. So this ball comes to this position. Now the Sun is over here. Now here the Sun, but see the Sun over here. So the Sun, to reach the same spot, you need to go for 4 minutes. Again, the rotate for 4 minutes again. So for 1 degree change is happening, right? This is what we call it as rotation and solar day and sidereal day.